So today we're going to venture into complex numbers. Before today, you have been told that like you can't take the square root. If you came down to a problem and you had the square root of negative 16, you'd tell me no solution, right?
Huh?
How about I spell it right?
-4.
It's what's different about it.
What's a negative?
Okay, so you can't take the square root, fourth root, sixth root of a negative number, correct? So that's before today. After today, you'll be able to tell me that this is plus or minus 4i. So we're going to solve these two equations just real quick. So a is x squared minus 16 equals 0. And we would do what with it? How would we solve this? Add the 16, or you could factor it. Yes?
Yes.
So you want to add or you want to factor?
Add.
Add. So you have x squared equals 16. And then what? How do you undo squaring something?
Divide it.
Square root it. But when we square root something ourselves, there's two answers. Yes? What are those two answers?
What?
Positive and negative 4. When we put that square root in, there's two of them, because negative 4 squared is 16 and 4 squared is 16, correct? Okay, so what about the next one? X squared minus 9.
You'd add the 9 over. Oh, wait, no, you wouldn't.
You'd just take the square root, wouldn't you? Okay, and we'd have x equals the square root of negative 9. And we cannot do that at this time. Okay, so because what we have here is the square root of negative 1 times the square root of 9. Yes? What's the square root of 9? It'd be plus or minus 3, wouldn't it? But we have this problem with this negative square root of 1. But if we can't do anything with it, what happens when our math has it? And that was an issue. Huge issue. Especially when they started dealing with electricity and how they were going to transport or move or relay electricity from one location to another. They were doing these, and it happened before then. But when they're doing these equations, this negative square root thing kept happening. Okay? They get a number, but it'd be a negative square root. And you can't just say, no solution, we're done. Because imagine your life with no electricity. What would be different about your life without electricity?
Everything. Literally everything.
Every single thing you do in a day has to do with electricity, yes? You wouldn't have a hot shower.
I'm alright with that.
I can smell that. I can smell that. You wouldn't have your cell phone, TV. You wouldn't wash your clothes the way you do.
You won't have cars.
You wouldn't have cars.
Ew.
I just read things.
Don't suck.
Can you imagine our life without electricity?
Don't suck.
Yeah.
Yeah.
So, like, even now, if you go, oh, I want to be off-grid, I want to live off-grid, well, you'd have a solar panel. Well, doesn't that have to do, like, the same kind of computations to figure out how to get the electricity from the panel to your house? Yeah. So without the technology or the math that allowed the electricity transport technology to evolve, you would have absolutely nothing. You'd be boiling your water on a gas stove or outside.
Gas doesn't take electricity?
No,
I didn't know that.
a gas stove, unless it has like an electric starter in it, but a gas stove can, like the older ones, could perform without electricity. Okay, so the solution that we have here is we have to deal with this negative square root. Well, the square root of negative 1 equals I. That's what it is. The square root of negative 1 is I. You want to write that down.
Oh.
Once we put that I in there, we are no longer in the real number system. We are in what they call the complex number system or the imaginary number system. Complex is because it has, imaginary is only numbers that involve I's. Real are only real numbers. Complex is both. Has real numbers and imaginary numbers. That's why it's called complex. So the solution to this problem would actually be plus or minus 3i. So using the square root to solve the equation, write your solution using imaginary numbers as needed. Okay, so, oops, didn't even touch it.
I stands for imaginary numbers.
I stands for I is equal to the square root of negative 1. It is an imaginary number. That's probably why they use I, but I doesn't stand for imaginary number. I is a replacement of the square root of negative 1. When you do your problems, you will have an I to the first degree or nothing, because we will figure out how to deal with everything above degree of 1, like I squared, I cubed, I to the fourth, all that. So when your problem is done, I will only have a exponent of 1. So x squared minus 5, what would I do to both sides? Square root it. Is 5 a perfect square? No. So it's going to be plus or minus, right? And it's going to be the square root of I, because we've learned if you can't do it, you just do square root of I. But what's the negative going to give me? I. That negative right here, because that would be the square root of negative 1 times the square root of 5, wouldn't it? And what does the square root of negative 1 equal? I. So x squared equals negative 72. What am I going to do? Square root both sides. Now, 72, what's the perfect square in 72?
36.
36 times 2, right? Is 72? So what's the square root of 36?
6.
6. And then the square root of 2. And what's this negative going to give me? I. Now you notice I put this little like thing on the bottom, like right here at the end, to know what's in the square root and what's out the square root. The I is always at the end. Always at the end. Now, I know some of you were going 9 and 8 for 72, yes? Okay, 9 is a perfect square, 8 is 4 times 2. So the square root of 9 is 3, square root of 4 is 2, so 2 times 3 is 6. Okay, so if you didn't see 36, you could have done it with 9, 4, and 2, yes? Questions? Anytime you have an even root, I said even root, of a negative, what are you going to have in your answer?
I.
An I. Because I could have the cube root of negative 8. What would give me a negative 8? What's the cube root of 8?
Cube root?
2. But I could do negative 2 times negative 2 times negative 2, couldn't I? Okay, so you can take the odd root of negative numbers all day. It's the even roots that you can't.
That all it is?
It gets more, but basically. Okay, so what happens if we have I squared and I cubed and I to the 852nd? Okay, so, well, I just touch it and it just goes. Okay, so I equals the square root of negative 1. You will never have the square root of negative 1 in your answer. You will have I. Yes? But we have to deal with what happens when we get I squared. Well, I squared would be the square root of negative 1 squared. Yes? What happens when you square a square root? Don't you get what's inside?
Yeah.
So I squared equals
Negative one.
negative 1. So I cubed, wouldn't that be I squared times I? Yes?
Yeah.
Well, what's I squared equaled?
1.
What?
1. Yes.
What does I squared equal?
Negative 1.
Negative 1. So I had negative 1 times I, which would give you negative I. Because you can have I in your answer to the first power. So if you have I cubed, it's just negative I. So I to the fourth, well, wouldn't that be I squared times I squared? Yes? Okay, well, what's I squared?
1.
Negative 1. What's I squared? Negative 1. And negative 1 times negative 1 is?
Negative 1. Oh, positive 1, my bad.
Okay, so do you see how any power, 1 to 4, can be reduced down to a first degree, like 1? Okay, so I'm going to write it here. The square, well, I'm going to do this. So the square root of negative 1 is what? What do we put? If I have the square root of negative 1, what do I put? I. What's I squared? Negative 1. What's I cubed? Negative I. And what's I to the fourth? 1. So this just repeats. Okay? So what if I do want a I to the 854th? I don't want to keep writing these down until I get to 854. Do you? No. So I to the fourth would be like ideal, wouldn't it? Like, so if I took something, I to some power to the fourth, when I take a power to a power, I multiply, yes? So if I'm going to go backwards, I'm going to divide. So let's divide 854 by 4. See what we get. 4 goes into 8, how many times? 2. 4 goes into 5, how many times? 1. With 1 left over. So 4 goes into 14, how many times?
3.
3. With what left over? 2. So this whole thing equals 1, doesn't it? And what's I squared equal?
Negative 1.
Negative 1. So the answer to this is 1 times negative 1, which is negative 1. Every single time, doesn't matter. Somebody give me something obnoxious. Cooper, give me a number. I to some random power. Give me a power.
124.
124, that's it? That's not obnoxious. How about 1,249?
I'd say that.
That's what he was gonna say, Ms. May.
Oh. Okay, so the first thing I do is divide it by what? 4. Because I to the fourth is 1, yes? And then I put my remainder over here. This is going to be my answer, basically, over here. So 4 goes into 12, how many times? 3. 4 goes into 4, how many times? 1. 4 goes into 9, how many times? And what's my remainder? So this whole thing is 1. And what's I to the first? We just write I to the first, don't we? So the answer is, what's 1 times I? I. That's it. So could I give you any power of I wanted and you could tell me what it was?
What if the power of I is a prime number?
Hmm?
Do that? Like, can it be a prime number?
Well, it can be a prime number, but 4 can still go into it. Not evenly. But it can, we're not talking about even. We're just going to divide it by 4 and our remainder is going to be our solution. So if we came out with some, let's say, I to the 738 to the 4th times I cubed. Well, this is just 1. And I cubed is negative I. So the answer is negative I. This right here is your essential answer because the other one's just 1. It's your remainder. So what happens if your remainder is 0? Then the answer is just what? 1. Because there's no remainder. Okay, so imaginary numbers. I kind of discussed it already. Imaginary number is BI. B is a non-zero real number. Let me erase some of this so it doesn't confuse you. B is a non-zero real number, and I is equal to what? Square root of negative 1?
Yes.
A complex number in standard form, we always write them in standard form. That's not a negative. Always in standard form. I don't tell you to write them in standard form. You always write them in standard form. Is A plus BI. A is a real number. And BI is your imaginary number. Always in that order. Got me? Okay, they include real imaginary parts, whatever. So I have negative 6 plus 4i is an example of a complex number. 7 minus I squared of 2. What's wrong with that? Should be 7 minus what? Square root of 2. I. I should always be in the back. I'm going to tell you, your book sometimes doesn't do it. Because the way they do square roots, how they don't end them, if they would write it 7 minus the square root of 2i, would you put that I inside? Yep. Half the time, it probably wouldn't be that close, but I would get the question, is that I in the square root or not in the square root? Is I ever going to be in a square root? No. And then I have 0.5i or 1/2 I. Now I wrote it like that. Normally I could put the variable in the numerator, correct? But in this case, I has to be completely separate. So it's 1/2, and you see the I, how I put it off to the side. I can see that. Okay. Am I good? Okay. Add and subtract the complex numbers. Write your answer in standard form. So I have, what is the sum of 4 minus 7i and negative 11 plus 9i? So sum means to what? Add. So I legitimately have 4 minus 7i plus negative 11 plus 9i. This is combining like terms, guys. Complex numbers have real and imaginary. Yes?
Yes.
So real to real, imaginary to imaginary. So what 4 is real? What's the other real number?
Negative 11.
Negative 11. So I have 4 minus 11 plus 7i. What's the other imaginary?
9i.
Plus 9i. So what's 4 minus 11? So negative 7. And 7i plus 9i is 16i. So plus 16i. I'm just showing you how you rewrite it. I would not do this step ever. Do you know how to combine like terms? Yes. That's all you're doing.
That's it?
Yeah, that's it.
So we're doing today?
Okay. Oh, I wrote it over here. Well, no, we're multiplying, divide. We're doing more than just,
Okay, I was gonna say.
yeah. So difference means to what?
Divide. Wait, subtract.
Subtract.
Sorry.
So I have 3 minus 2i minus negative 4 plus I. So with addition, I just added, right? But with subtraction, what do I have to do first? What do I have to do with this right here?
Make it positive? Wait, no. Distribute it?
Yeah, I have to distribute it, don't I? Don't I have to distribute this negative in? Yes? So I basically have 3 minus 2i, what? Negative and negative is a,
Positive.
so plus 4 and
Minus I.
minus I. And then combine like terms. Real to real, imaginary to imaginary. So, Alex, what's my answer?
6.
What?
Real to real. What are my two real numbers?
3 and negative 4.
I have a 3 and a positive 4.
I also got the parentheses one. That's why I meant my.
What's 3 plus 4?
7.
7. What are my imaginary numbers?
Negative 2 and negative 1.
Negative 2 and negative 1. So I have what?
Negative
Negative 3.
Negative 3.
3. I.
I. If for some reason you did your work and you had this, oops, would you stop here? What do you need to do with that? Negative, you need to flip it, right? So it would be 7 minus 3i.
That's all. That's simple.
Am I good to go to the next? Okay, so what if I ask you to multiply? Guess what you're going to do?
Distribute.
You're going to distribute. So I have negative 2.5i times 8. So 25 times 8. 8 quarters is how much?
$2.
$2. So negative 20. Actually, it's negative 2, isn't it? No, 20. I? So 2.5 times 9 would be
22.5.
so 22.5 positive or negative.
Positive.
So plus 22.5. And I have I times I, so I have I
Squared.
squared. What was I squared?
Negative 1.
Negative 1. So this is 22.5 times I squared, so it's 22.5 times what?
Negative 1.
Negative 1.
Negative.
So it makes it just negative, doesn't it?
Yeah.
Okay, can I leave my answer as negative 20i minus 22.5? Nope. So it's going to be negative 22.5 minus 20i. Okay, so 2/5 I times 10 plus 5 halves I. So I'm just going to do what?
Distribute.
Distribute. So 5 goes into 10 how many times? Twice. So 2 times 2 is?
4.
So 4i plus right? Well, I have 2/5 times 5/2. It's 2/5 times 5/2. 1. And you have I times I. I squared. Can I leave it like that? What is it?
How did you get the 1 again? Sorry.
2/5 times 5/2.
Oh.
Can I leave any? What is the only power of I can leave? What's the only power of I can leave in an answer? 1. What is I squared?
-1.
-1. So -1 times 1 would be, this whole thing would be -1. So I have -1 plus 4i. How did I get -1 plus 4i?
Because you put the negative in front of the positive.
Yep, you just had to put the real number in front of the imaginary, right? Okay, I have 3 minus 2i and 3 plus 2i. What do I need to do there? I need to distribute. So do it. That. Did you get this? Why not? Okay, when you FOILed that, you should have got 9 plus 6i minus 6i minus 4i squared. Correct?
Oh, wait, yes.
Because I here to here, here to here, here to here, here to here. Did you forget one of those?
Yeah, I forgot the 2i and the 2i.
Okay. So when you do that, the plus or minus 6i reduce out to 0, yes? Yes?
How did you get a +4?
Well, what is
Oh,
I squared? What's I squared, guys?
-1.
-1, and a -1 times a -4 is a positive 4.
I did that right.
So your answer is 13.
I did that right. I shouldn't distribute my negative.
Okay. So what do you think this next one's going to be?
Distributing.
We distribute it
But
again.
it's the same thing. Oh, no, it's not.
Well, let's see. Let's do it. You do it, I do it. Hopefully you get the same as me this time. Don't get scared with the half. What's a half times a half?
1.
1/4.
1/4. 1 times 1, 2 times 2. Half of 2 is 1. I'll go with half of 2 is 1.
Don't even make it a fraction.
How is it not a fraction?
No, because I just did 4 and 1/4.
Oh, that's gross. Don't do that.
Do it improper?
Yes, I want it improper. Always. Mixed numbers only if you have an application problem and you're telling me a measurement. Because can you do any math? Well, you can, but can you do a whole lot of math with a mixed number? No. You got to make it improper, don't you?
Yeah.
Did you guys get 17/4?
Yeah.
Okay. So, just because there was that fraction, but I want to talk about what happened. What do you notice about this and this?
They're the same.
thing,
They're both the same eye. There's positive.
Aren't they difference of squares?
Yeah.
Yeah? But since we have an I there, well, difference of squares is also known as a conjugate.
Ew, that's a big word.
And since we have an imaginary number, they're called complex conjugates. And what do you notice about once I multiplied them both out? What kind of an answer did I get?
A fraction. Oh wait.
What kind of number did I get?
Number?
A what?
What?
What'd you say? What kind of a number? Guys, we've been talking about real numbers, imaginary numbers, complex numbers. What kind of number did I get?
Get a real number.
I got a real number. Is that important?
Yeah.
Do we need real numbers to be able to do real math with them?
Yes.
Yes. So we will be, not today, but tomorrow we will explore the conjugates more. And we'll be making them. So if I told you I had 4 minus I, what would its conjugate be? 4 plus I. And when I multiplied that out, it would be 17. Because the middle two terms are always going to zero out, right? What's 4 squared?
16.
16. And I times I is I squared. But it would be negative I squared. So negative 1 would be a positive 1. So you would get 17. Okay? So I don't think we have any more. I think it just goes on to complex conjugates. And we will have time. You'll write that tomorrow. So today you have a worksheet. It is 1 through 60, but your assignment is 1 through 30. Will these take you that long?